Yes, good morning students. In the first volume, we discussed about coordination compounds. I told you about difference in the double sort and coordination compounds, and then we studied the terms central metal atom or ion and ligands, and then type of ligands on the basis of number of donor atoms present in a ligand. So we discussed about monodentate ligands, didentate ligands, tridentate ligands, hexadentate ligands, that is polydentate ligands. There is one more term, chelate, or may also be pronounced as chelate. CHELATE. Didentate ligands and polydentate ligands. They form ring structure with central metal atom, and they are called chelates. Here, take the example of En whole twice Cl2. En is the abbreviation of ethane 1,2-diamine. En is the abbreviation of ethane 1,2-diamine. The formula of the ligand I have told you on the last turn is CH2 NH2 CH2 NH2. It has two donor atoms, this nitrogen and this nitrogen. So it forms ring structure with copper. Let us see how. Carbon, single bond carbon, CH2, CH2N. H2 and H2. One molecule of ligand, other molecule of ligand, CH2, single bond CH2, NH2, NH2. So such type of ring structure is formed, and it is called chelate, or may also be pronounced as chelate. The ligands which form chelates or chelates are called chelating ligands. So this is a chelating ligand. To all polydentate ligands form chelates, and that is why they are called chelating ligands. Now we come to another class of ligands, ambidentate ligands. See the example. nitro ion. This may be written in two ways, and also may be written as N double bond O single bond, to this nitro group may be linked to central metal ion through oxygen, or may also be linked through nitrogen. But at a time it will be linked only with one atom, either by oxygen or through nitrogen. तो दिस इज एन एम्बिडेंटेट लिगेंड्स. तो ऐसे लिगेंड्स जो दो एटम्स के थ्रू लिंक हो सकते हैं, सेंट्रल मेटल एटम या आयन से, लेकिन एक समय में एक टाइम में एक ही एटम से लिंक होते हैं, वो कहलाते हैं एम्बिडेंटेट लिगेंड्स. इट्स नेम इज नाइट्रिटो एम, nitrito because it is linked through oxygen to the central metal atom, and it is written as nitrito N because here nitro group is linked to central metal atom or ion through nitrogen, to nitrito O, nitrito N. Other example is thiocyanate. It may also be linked in two different manners, either through S or through M. It is written as thiocyaneto S, and it is written as thiocyaneto S M. So these are the two examples of ambidentate ligands, and I think you have understand well about ambidentate ligands through these two examples. Note down. So now we are going to discuss the next term, coordination entity. Coordination entity. See the example, CO NH3 whole 6 Cl3. Another example, CuEN ethane 1,2-diamine whole twice Cl2. The complex has two parts. One part is written within square bracket and the other part is ionic part. Central metal atom in this example is cobalt and the ligand is ammonia, and in this example center metal atom is copper and ethane 1,2-diamine is ligand. Center metal atom and ligands combinedly constitute what is known as coordination entity. So the part of the complex compound in these examples CO parenthesis NH3 whole 6, and in this example Cu parenthesis ethane 1,2-diamine whole twice are coordination entities. Center metal atom and ligands combinedly are called coordination entities. तो ये दोनों coordination entities हैं. Now the next coordination sphere. Central metal atom and ligands are written in square bracket. Central metal atom and ligands, when written in square bracket, then this combination within the square bracket is called coordination sphere. So cobalt, ammonia, they are written in square bracket. So this part and here this part is the coordination sphere. Very simple. Now next is coordination number. Cn. Here in the same example, this is very important term. In the same example, I have told you that ligand provides one or more donor atoms for the formation of coordinate bond. Here ammonia provides nitrogen as donor atom, and here in ethane 1,2-diamine it provides two donor atoms for the formation of coordinate bonds. In this example, coordination number is 6, and in this example coordination number is 4. Again, coordination number. There are 6 ammonia molecules. So ammonia forms 6 coordinate bonds with cobalt. Coordination number is 6. In this example, ethylene diamine, it has 2 donor atoms and there are 2 groups of ligands. One ethylene diamine, other ethylene diamine. 2. So there are 4 donor atoms it provides to copper for the formation of coordinate bonds. Therefore, coordination number of metal is 4. Other examples: Ag, NH3 whole twice, Cl. In this example, you see that ammonia provides, there are two molecules of ammonia, and each molecule of ammonia provides one donor atom. So two molecules of ammonia are providing two donor atoms for the formation of coordinate bond. So there are only two coordinate bonds formed with silver. Therefore the coordination number is 2. So from this discussion, it is clear that the coordination number is the number of the donor atoms present in all the ligands which form coordinate bonds with central metal ion. Note down. One very important point here is that if ligand also forms pi bond, then the pi bonds are not counted. Only sigma bonds are counted. A ligand may form a pi bond also, but in most of the examples only sigma bonds are formed. But if pi bond is also formed, then it is not counted when we discuss the coordination number. Only the sigma bonds formed between ligand and central metal ion are counted for coordination number. So this is very important. Now the next term regarding coordination compounds is coordination polyhedron. Note down, coordination polyhedron. We know that coordinate bond is also a covalent bond, and covalent bonds are directional in nature. So these coordinate bonds are also directional in nature. Ligands forms coordinate bonds with central metal atom, so they spread themselves around the central metal atom in particular direction in the space. For example, take the example of this compound, cobalt is the central metal atom, and 6 ammonia molecules are ligands. These 6 ammonia molecules forms octahedral shape. Similarly, other example, in this example, copper is the central metal atom and ammonia molecules are directed on the corners of a square. This is square shaped. One more example, nickel tetracarbonyl nickel. Nickel is the center metal atom and carbonyl groups are directed towards the corners of a tetrahedron. So it provides a tetrahedral shape to this. There may be trigonal bipyramidal shape and so on. The most common shapes are octahedral, square planar, tetrahedral. These are the most common shapes. So spatial arrangement of ligands around the center metal atom or ion constitute what is known as coordination polyhedron. Now note down, and the next term is homoleptic and heteroleptic and heteroleptic complexes. See the example, the same example. Other example, in this example you see that all the donor atoms are same, the same ligand, same donor atom. Here you see that there are two types of ligands. One is ammonia and other is chloro. This is an example of homoleptic complex, and this is an example of heteroleptic complex. तो अगर किसी कॉम्प्लेक्स में सेम डोनर एटम्स हैं, एक ही लिगेंड है, तो वो होमोलेप्टिक कॉम्प्लेक्स होगा। और अगर अलग अलग लिगेंड्स हैं, दो तरह के लिगेंड्स हैं, तीन तरह के लिगेंड्स हैं, चार तरह के लिगेंड्स हैं, जैसे इस एग्जांपल में है, तो वो हेटेरोलेप्टिक कॉम्प्लेक्स होगा। और एग्जांपल एक देख लीजिए, CO Cl SO4 NH3 whole thrice. So in this example there are three types of ligands: ammonia, sulfate and chloride. So this is also an example of heteroleptic complex. तो होमोलेप्टिक कॉम्प्लेक्स में एक ही तरह का लिगेंड होता है, डोनर एटम सेम होता है, जबकि हेटेरोलेप्टिक कॉम्प्लेक्स में दो या दो से ज्यादा तरह के लिगेंड्स होते हैं। डोनर एटम्स सेम भी हो सकते हैं और अलग भी हो सकते हैं। अगर अमोनिया के साथ इथेन 1,2 डाइमीन भी है, तब डोनर एटम सेम दोनों में हो जाएगा, नाइट्रोजन, बट द लिगेंड्स आर डिफरेंट, देयरफॉर इट विल बी ए हेटेरोलेप्टिक कॉम्प्लेक्स. So this is all about homoleptic and heteroleptic complexes, and now we are going to discuss the very important topic, Warner's theory of coordination compounds. To note down Warner's theory of coordination compounds. Yes, Warner's theory of coordination compounds. Alfred Warner was a Swiss chemist. He prepared coordination compounds. He studied about the coordination compounds. He studied the physical and chemical properties of coordination compounds. On the basis of his experiments, he gave a theory of coordination compounds, and that theory is known as Warner's theory of coordination compounds. So let us see how they reach the points of the theory. Very important. Warner took the example of CO, Cl3, 6NH3. Another compound CO, Cl3, 5NH3. Another compound CO, Cl3, 4NH3. One more compound COCl3, 4NH3. One thing I would like to tell you before going to discuss this experiment of Warner. See here, MCl. M is a metal and Cl is chloride ion. So if we take 1 mole of this MCl, it has 1 mole of chloride ions. If we add excess of AgNO3 to this any compound, then we will get 1 mole of AgCl. Right? It's very simple. If you take NaCl and dissolve in AgNO3, you will get a precipitate of white precipitate of silver chloride. If we take another ionic compound in which the metal is bivalent, here the metal is monovalent, here the metal is bivalent. So in one molecule of MCl2 there are 2 ions of chloride. Now if we take excess of AgNO3, then we will get 2 moles of AgCl. And if we take any compound, any chloride of trivalent metal, this is trivalent metal, and add excess of AgNO3, then we will get 3 moles of AgCl. Right? Now see what he did. He take this compound, added excess of AgNO3 to this compound, and he got 3 moles AgCl. Right? In this compound, he added the same amount of HNO3, that is excess of HNO3, and he noted that only 3 mole of AgCl is formed. Only 2 moles, not 3. Only 2 moles of AgCl is formed. The color of this compound was yellow and the color of this compound was purple. He added excess of LgNO3 to this compound and he got only 1 mole of AgCl. He added 1 mole excess of AgNO3 to this compound and he again got 1 mole of AgCl. The colors were different. The color of first one is green and other one is violet. The important point here which is to be noted is that all these compounds have 3 chloride ions. When this compound is treated with excess of HNO3, we get 3 moles of AgCl. This compound 2 moles of AgCl, this compound 1 mole of AgCl, and this compound also gave 1 mole of AgCl. Why? ऐसा क्यों हुआ? Let us try to discuss. किस तरह से उन्होंने इसे एक्सप्लेन किया? See here, there are 3 ions. When excess of HNO3 is added, all the 3 ions combine with 3 ions of silver and form silver chloride. 3 ions combined with 3 ions of silver form 3 moles of AgCl. Here are also 3 ions, but out of 3, 2 are free to add with silver, and that is why 2 moles of silver chloride is formed. Out of 3, only 2 are free to combine with silver ions to form 2 moles of silver chloride. One is not freed. In this compound, 3 chloride ions, only 1 silver chloride is formed. As here, it means 1 chloride ion is free to add with silver and form 1 mole of silver chloride. The same is here. All the 3 ions are free and form 3 moles. Only 2 ions are free, form 2 moles. Only 1 ion out of 3 is free, and here is also only 1 ion out of 3 is free to form 1 mole of AgCl. To explain the experimental fact, he gave theory, and that theory is known as Warner's theory of coordination compounds. So let us discuss the theory one by one. पहला पॉइंट इनका यह है जो इन्होंने बताया कि मेटल कॉम्प्लेक्स कंपाउंड्स में 2 तरह की वैलेंसी, 2 तरह का वैलेंस शो करता है, प्राइमरी वैलेंस एंड सेकेंडरी वैलेंस. मेटल इन कॉम्प्लेक्स कंपाउंड्स, center metal shows 2 types of valence. One is primary valence and the other is named as secondary valence. Primary valence, second point, primary valence is satisfied by anions, negatively charged ions, which are free to form AgCl, to combine with silver ions and to form AgCl. And the secondary valencies are satisfied by coordinate bonds formed by the atoms, formed by the groups, and that is why those chlorine ions which are coordinated with central metal atom or ion, they are not ionized, and that is why they do not add with silver ions to form silver chloride. So in this compound, these are anions, these are present as anions. They satisfy primary valencies, and in this compound the primary valency is 2 and the secondary is 1. 2 ions are free to combine with Ag silver ions. Here secondary valency satisfied by chloride ions is 2. That is why primary valency is 1, and that is why one chloride ion combines with silver and form 1 mole of silver chloride. And similarly here. So now the question arises, in these two compounds 1 mole of AgCl is formed. Even the compounds are different. The color of one is green and the color of other is violet. This is because of isomerism. Coordination compounds also show isomerism. So these two are the isomers of one another. That is that they are different compounds, their spatial arrangement is different, and that is why they show the same formation of 1 mole of AgCl. But because of they are different compounds, that is why their colors are different and they are isomers of one another. So students, note down, और NCERT की book is available online. Go through the book, see the questions. If you have any problem, through WhatsApp, solve it. Send the questions, then I will solve the problems and send through the WhatsApp. Thank you very much.